Hey guys, I'm going to try to do a quick review of our exercise 2, and then probably the beginning of this week I'll do a quick review of exercise 3 because I know some of you are still working on it. Pretty much everybody's done with exercise 2 though, so I'll do a quicker review. So as you'll see on the right here, this is the chart that you should be going by. If you're not looking at this and you're just trying to remember off the top of your head what's what, this, to me anyway, like seeing this visualization makes it a lot simpler to understand what's going on. And they want you to use four timers. There we go. So we'll have, so just right on the face of it, when you look at it and you try to think, how am I going to use 4 timers when there's 6 lights? If you notice, the red is on the same time as the green and the amber from the opposite side are on. So you'll make one for this green, one for this amber. This red one will just have 2 parallel contacts. When either the green or the amber are on, it'll also make this red on at the same time, because you see the red's on the entire time, either green or amber's on. And then it basically switches the other way. The green and amber on the other side are on in series, and the red for the opposite side is on the entire time either one of those is on. So you'll need a timer for this green, a timer for this amber, a timer for this green, timer for this amber, and that's your 4 timers. And these reds are just going to be on if one of the green or the amber on the opposite side is on, but you don't need a timer for them because these cumulatively make up the amount of time that that red is supposed to be on. So we'll have 2 8-second timers, 2 4-second timers, 6 rungs with the light outputs on them. So I'm going to try to run through this here quick here. So we'll need 6, 7, 8, 9, 10. Should need 10 rungs. This thing's going kind of slow. Try not to make this take a long time. And I probably put one too many, but we'll see. So we're going to have 4 timers on top. Go to timer, TON, 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 and TON, which I did not drop on the right spot. There's our 4 timers. We're going to have our 6 outputs for our lights, but I'll address these timers a while I'm here. And T4, 0. And they're going to be 8, 4, 8, and 4. So my preset's going to be 8 here, 4 here, 8 here, 4 here. And that's it. That's going to be my 4 timers. 1, 2, and then 3 and 4. And T4 1. T4 2. T4 3. So I got my 4 timers that I'm going to use. That should be all I need. I have my presets set, except for, wait, did only that one work? So only the one that I had addressed before I put the preset in and actually saved the preset. 8, 4, 8, and 4. Now they're in there. Okay, so these are going to be cascading timers. That means one's going to turn on the next one, which turns on the next one, turns on the next one. They're cascading, meaning falling down in order. Like you think of like a waterfall effect. That's basically what's happening. So what's going to happen is when this last one times out, you want the first one to start again. So I'm going to put a normally closed contact up here at the top so that this timer will start running as soon as the program starts being executed. But when it gets down here at the bottom, I want this last one to reset the first one and have it start over again. So it's going to be normally closed and it's going to be tied to this T43. I'm going to go to timers here. T43 done bit. T43. There's my done bit. There you go. So the done bit from this first timer is going to start the second one. So I'm going to have normally opens on the next 3, and they're just going to kind of cascade down from one to the next to the next to the next. And then once I reset this top one, it's going to reset everything because all these other ones are only going to be enabled when this top one has its done bit finished. And when I open this up, it's going to reset it. You'll see how it works. I saw some people were using resets. With this TON, time on delay, you don't need a reset. You can just interrupt the power. So whenever the enabled goes off, it automatically zeroes out the accumulated. That makes sense. You'll see how it operates here in a second. And so this one should be tied to that. And for whatever reason, I think you can't drag these like this in this program. Yeah, it's not gonna, that's not right. But you can drag them from here for whatever reason. If you hit the X on your simulation, you can bring up your window in the background, the one that you would normally see in Allen Bradley software. And then you can double click on T4 timer and it has all your table data for your timers. So the first column is the enabled, that's this, meaning it just has power to the timer. TT is timer timing, so anytime this timer is actually counting, that will be a 1 instead of a 0. Here is your done bit, the /dn means the timer accumulated, reached the preset, and it's done. Here's the preset value, which I typed in there myself, and it looks like 1 is still not right. This one is still 4 instead of 8. Why they're doing me like that? Timer. So here's my presets, 4, 4, and 8, and 8. Oh no, it was right. 8, 4, 8, 4. There we go. Yeah, I don't know why the presets in here are not correct then. When you look on here, it should say 8, 4, 8, 4, because you see the preset for T40 is 8, and on here, T40 preset says 4. It's not correct. Accumulated is 0 currently. If this was running, these accumulateds would be going up. So when T40 done bit makes, it should enable T41, T40 done bit. And again, you can drag them out of here, but they don't let you drag it off the screen. T41 done bit. It's going to go to there. And then T42 done bit. It's going to go to there. So before we do anything else, let's just make sure this is going to work and you guys can see the idea. You want to try to make it as simple as possible with the least amount of things in your rungs. So I saw all kinds of like parallel rungs and all kinds of extra stuff. People had like multiple outputs in series, output coils in series, and all kinds of stuff. This should be all you need for your timer section. They're just cascading timers. So this one makes this one turn on when it's done. When this one's done, it makes that one turn on, and they all just feed each other. Once it gets down here, it opens this up, which resets this one. So the done bit's not made, which opens this up. And when this done bit's not made, it opens that up. So in one scan of the logic, everything gets erased as soon as this done bit gets made, and then this closes again because the T4 3 done bit isn't made anymore because everything got turned off. So this closes and restarts the timer again. So I'll just download that quick and show you what that looks like. Most of you have something similar to this. Oh, you know what? My time base is 1/10 of a second. That's why everything's going super fast. But you can see how it just goes down through. Actually, it's probably better that they're going that fast. And then you can look at your timer. Everything's going probably too fast to follow, but you see how the accumulateds are changing until they meet the preset, and then the done bit goes to 1 as soon as they're equal. And the TT is the timer timing, so only during the time that it's it's enabled but hasn't met its the accumulated hasn't met the preset yet, the timer timing will be on. And the enabled is anytime that there is power getting to it. So this top one's enabled pretty much all the time. Just one scan when this done bit down here gets made is when it opens up and resets. But it happens so fast it looks like it's just always enabled. So yeah, let me. This is another good reason why you should check frequently to make sure what you think you're doing is really what you are doing. Because I didn't pay attention to that time base. I don't think you can change the time base in LogixPro. In the real software, you can change your time base. You can make it 1 second or 10 seconds, or you can move that decimal to be whatever you want the counts to be. Go offline here quick and change this to 80 and this to 40. And again, you'll see when you're writing real logic that you have to pay attention what the time base is, because it's not always going to be 1/10. You can make it multiple different things. I'm used to just setting my time base to 1 second. That's why I put 8, 4, 8, and 4, because generally when I write real programs with Allen Bradley software, I make the time base a second. It just makes more sense to me to make it a 1 second instead of 1/10 of a second. It's easier to remember and it's easier to follow what you're trying to do. So here are all my timers that I need. Now all I have to do is address my outputs to be on when they're supposed to be on. So I need these guys. It's probably a quicker way to do this, but This is how I'm doing it. Halfway there. 1, 2, 3, 4, 5, 6. That's all of them. And then I did have an extra rung that I didn't need there. There you go. So here's going to be my 6 outputs. So I'm going to make, I wonder if I can drag my outputs from here. 0200 is right here. And I can. So all these tables have all the information that you need. So we looked at our timers, and it has all of our timers and where they're currently at and what their accumulated and presets are. You can also look at your inputs and outputs and pretty much everything else that you would need to look at. So the red light on that simulation is output card 2 bit 00. So I go to 02 and 0 is right here, and I drag it right up to there. So I'm just gonna make it kind of look similar to these. I don't even have to look at the simulation or any of that. I can just go straight off these numbers. 206 and 205 is what I'm going to put next. So output, this should be the green light and the amber light that are going to be on, that are going to make the red light on, if that makes sense. And the first 8-second one is going to turn this 6 on. Let me put some contacts in here. So for 8 seconds, this output 206, this second output of my rungs here is going to be on, and that's this 8 seconds. So what do I want to do? I want to use the timer timing from T40. T40 timer timing, this bit right here, is only going to be on for the 8 seconds that it's counting. After it gets to done, the timer timing bit goes out because it's not timing anymore. And then it'll stay done while the rest of these go through. And the next one is 205. This should be on for 4 seconds in order next, and that's this timer. So it's the T41 timer timing. T41 timer timing, which is a 0 now because it's not counting, but as soon as that timer is enabled, if it hasn't reached the preset value yet, while it's counting, this will be a 1 in your timer table. And when that's a 1, since this is tied to it, 1 is true or high, or you know, all the different terminology used for a bit or binary digit, meaning it's, you know, on. So it's going to close this contact. It's normally open. Whenever that timer timing is activated, it's going to close this, and it's going to make that output turn on. Our red is on anytime either of those are on. So this 20 up here is our red. So we want to make some parallel rungs here. Drag that into there, and I'll put another one here. And this is just these same 2 ones. If either of those are made, and you could drag it off the outputs too. You could take these output addresses and put them there, and it would work the same way. I just think to me, in my head, it makes more sense if I can look at this and see that if either one of these are made, that provides a path for that red to be on. So we can look at our animation and make sure it's going to work right. But if you disregard the whole right-hand side of this, you see that the red is on anytime either of these are on. And that is what I have down here. This is the red address. And these are addressed for the 8-second timer, the first 8-second timer, and then the next timer, which is set for 4 seconds. So it'll go this one and this one. Let's download quick and double check that what we think is true is really true. Oh, I got to open the simulation. It's the first time I've opened the simulation this whole time. So here's that red that's going to be on anytime the green or the yellow is on the right-hand side. So it's on for the green, it's on for the yellow. And then we're going through the other timers that aren't connected to anything yet. But you see how they relate to each other. And now I have my right time base, so now we got to wait for the 8 seconds and the 4 seconds, and it'll reset up to the top and count back through and go through the same sequence again. We're going to go offline and quickly get the other half of this done here. So over here, we're going to have 202. So if you're in this and you want to get back to your simulation, you just hit the X, you just close that out, and it'll take you back. So really, it never closes anything. If you're in the simulation and you close it out, it'll show you your background stuff. And if you're seeing this, you're closing it out. You're not really closing it. It just flips back and forth between the two. I don't know why they have it set up that way, but that's how it is if you're trying to figure out how to get back to where you were. So I'm going to do this 202 for this green next. So I'm going to go to my outputs, and 202 is right there. And 201. So this is going to be kind of reverse order. I had the red one first and then the two colors. This one I'm going to have the two colors and the red one on the bottom. The red is 204. Oh yeah, I grabbed the wrong output. 204. The one above it should have been 201. There we go. 202 is going to be the second 8-second timer. So you can go to your timers, and you don't really even have to look up at the top. You can see that it goes an 8-second, a 4-second. That's the two we already addressed. This is going to be the second 8-second timer. Oh yeah, I do need a contact to drag it to though. Be that, and then the red one is going to have two in parallel. Timers. So 8-second, 4-second, 8-second. That's the second one I want here. And then for whatever reason, this little block drags you way farther down than you need to be when you're dragging these off the screen. So that's my 8-second and my 4-second. Those are my last two timers. That'll make this green and that amber in order. And while either of those are made, this 204 should be made. So I can just drag that address there and that address there. Now everything should work good. Of course, I didn't label anything or do any rung comments, but you can see I started out, I knew that I needed 4 timers and 6 output rungs for lights. So I put that many rungs on here. I put my 4 timers and my 6 outputs for my lights. And this is pretty, once you see it, and you have an explanation of like how to get these locations, and now that you know that there's a timer timing bit that you can use, and you know, now it looks pretty simple. It should anyway. Everything's just a single line with a normally open or normally closed contact, except for these two that are parallel for the reds. And this is the simplest way to do it that I know of. Of course, I should label everything now, but let's go to our simulation and download this. And we'll check and see how she works. So we should go to yellow on the right hand side, and the red should stay on. Now we should do a switch on both sides. There we go. And because your next one, this exercise 3, is built upon this exercise 2 base, if you were way off track on exercise 2, when you try to make the edits that they want you to make down here, it gets really complicated and really difficult if you don't have like a simple, easy to understand process on exercise 2. Sometimes you can make exercise 2 work and it's like literally impossible to get exercise 3 working if you've made exercise 2 in a complicated way. It just gets too much, gets to be too long and too much stuff interacting with itself. But yeah, you should only have one output for each light. You shouldn't have multiple outputs for the same light, and you shouldn't have outputs in series. Every single one of these lines only has one input on it, except for the 2 for the red. They just have a parallel rung underneath the main rung, so that obviously either of these on this side make that red light go on. So hopefully that clarifies some things and makes it a little easier to understand and a little more simple. Just some foreshadowing of when we do exercise 3. The only difference is this 1 second timer. So we have this 8 second and 4 second for the green and the amber, just like in exercise 2. And then we have a 1 second timer that both of the red lights are on. You see this red light and that red light. So we would just add another 1 second timer and add 2 more rungs on here where our reds are, for this 1 second timer and this 1 second timer. So this top red actually starts over here. That's what this R is, and wraps around and goes that way. So both reds are on for this 1 second timer, and both reds are on for this other 1 second timer. So we would add, after our 8 second, or after our 4 second, we would add another 1 second that cascaded, and then after that it would turn on your 8, and then your 4. This 4 would turn on another 1 second timer, and basically you just have 2 more rungs here. On my rung 4 and rung 9, you have 2 more parallel pathways for the red light to be on, and they would be this timer and this timer. So it would be T4 4 and T4 5 would be my addresses that I would also be able to have these red lights on. And then you just have to put them in the middle of the cascade. So it would go 8 4 1 8 4 1. That's essentially what it is, but after more people get done with it, I'll do like a walkthrough like this and explain it more in detail. But it should be pretty easy to follow along if you're following along what this looks like. It's almost the same as this, except right in here you'd have a 1 second timer, and right in here you'd have a 1 second timer, and you would just have two more pathways on your 2 reds, and one for this 1 second and one for that, because they're both on during those 1 second timers. And that's essentially how you get it. Okay, hopefully that cleared some stuff up for everybody.